What is up, everybody? How's it going? So today we're going to pick up where we left off with the parser. So I'm going to go up here and I'm going to do a search for parse class declaration. And when I go here, I'm going to go into our class block. So as I mentioned before, it's going to start to get a little bit more difficult when it comes to processing things. And I'm still not finished with the parser completely yet. Like, I'm still working on it. So there's probably going to be some things that we're going to skip over and just come back to later, which is totally fine because, again, when you guys are parsing or when you guys are writing your parser, you want to get the fundamentals down first, and you can kind of focus on the other insignificant details later. So the first thing that we're going to do is we're going to talk about constructors. So with constructors, constructors look as follows. So if I go here and I try to create a constructor for this list class, so I'm going to remove this code here. If I try to create a constructor for this class, I'll have to say list, which is the name of the class, parentheses, and then, I don't know, some params. So let's say initial data of type T, and assuming that T is not going to be an array, you can do this. Arrays are not supported in my, I mean, they are supported in my language, but not syntactically. Um, so just keep that in mind. But yeah, so like this is basically the formatting for constructors. So let's kind of see how I process this. So first, in order to pick whether or not it's a constructor declaration, I have to do two things. So I have to first check to see if it's not a keyword and it's an identifier. And then I need to check to see if there's a left paren, because it's a challenge, right? I can't just assume that any token that starts with a name is a constructor. It basically has to follow um, this immediately afterwards. Because me knowing my grammar and how everything is constructed, there isn't a situation where I could have a syntax that has like an identifier and then immediately following a left paren. So based on that, that's how I know like that this is a constructor parameter. And of course, we're already processing the access types at the beginning. So if I go back here to class declaration and class block, we're already processing the access types. So if I had a public constructor, or if I had like a private constructor or whatever, that information is already going to be processed. So we're really just looking at this here. So once we've determined that, then we can keep going. So if I scroll back down, constructor. All right. So again, remember as usual, make sure you pass in the branch and not the AST. So once you do that, constructors are pretty small. There's not much involved when it comes to processing these. So all you need to do is just create a branch, call it AST Constructor Declaration. You do your customary access type handling, so you add the access types, and then you free up the list. And then you want to decrement the current token. So you want to go back one token, right? Because typically when we're looking for this, unlike other things, like for instance, if you're processing like a function, it would start with the keywords def, so like def, and then it would have like the identifier. So, but in this case, we immediately check the identifier as the current token. So we just want to go back one character so that way we can consume it properly. Once we do that, we want to parse a utype arg list. Now, I don't remember if we've gone over this, so I'm just going to quickly go over it. So basically what a utype arg list represents, oh yeah, we actually did go over this because we talked about it when we were mentioning function pointers a couple episodes back. But just to kind of recap, basically a utype arg list is going to be a list of utypes that are arguments. So you want to create your branch ASTU type arg list. You want to make sure you expect a left semicolon or a left paren. You want to immediately check to see if the next character is not a right paren because you can have no parameters. Once you do that, you want to parse utype arg. Then you want to check for a comma. If so, expect the comma and parse another utype arg. And utype args are formatted as follows. You create a branch immediately called utype arg, and you check to see if it's a variable declaration. So you do your check, And all it does is it just checks to see if the current token is a identifier. So basically, if the current token plus 1 character is an identifier, and plus 2 characters is equal to this right here, then that means that we need to immediately process this variable. Now, if you guys remember, I also had another function called parse utype_arg optional, which allowed the user to only process the type. So parse utype_arg forces you to have to provide both the name of the argument and the type of the argument. So that's why you have to process the identifier, consume the token, and then process the utype here. So just keep that in mind when you're processing it. And then if it doesn't get processed properly, if it's not formatted in the way that we're expecting, where it's a variable and then a colon, then we say a incorrect error message. So here I'm actually going to change this expected variable declaration. So that is parse utype_arg. And then of course you want to return true if you parsed it successfully. Otherwise you want to return false if it didn't get processed successfully. So if we back out of there, so once you process your utype args, then you're going to process a block. So blocks are going to be pretty customary in my language. So if you guys remember, I had different types of blocks. I had class blocks, I had interface blocks, and typically they were about the same thing. This will basically represent anything inside of this block function shall represent anything that can hold statements. So classes can't hold statements, so you don't want to use this part function for classes because this holds what's called declarations. So in my language and in your language as well, you should differentiate the difference between declarations and statements. A declaration means you're going to declare something. So like you're going to have a variable called size, and that's going to represent the size of this list class. So how many elements do you have? And then that can be like an int, and you can assign the default value to, I don't know, let's say you had like some variable that was a constant called default value. So let's say default value is another variable, constant default value is equal to 10. So let's say we had, some other variable called default value. So for every time we create this list object, the assumption is that the size of the list is going to be initialized to 10. So what these are declarations because you're declaring something new that hasn't been created yet. So you're declaring a variable here, you're declaring a function, or more specifically, a constructor. And then statements use declarations. So that's kind of the concept in my language. Hopefully that makes sense for you guys. But yeah, so let's kind of just go back to parse block. So once we're in parse block, this is going to be the function that's used for a ton of things in our language. So we're just going to call this function anytime we need to process it. So in order to parse a block, it's pretty simple. All you need to do is create the AST block function or the AST block enum. Once you do that, then you want to have your curly flag or your curly boolean. And then you want to check to see if the next token is a bracket. So the reason why you want to do this is because, so this is probably a bad example, but let's say we had like an if statement in here. Let's say initial data is equal to null. Now, typically, I know you guys have probably programmed in languages before where you can have like the standard brackets here, which denote anything inside of this or these brackets represents the data that is going to be processed if this case is true. But you can also support, like, I don't know, let's say if initial data is equal to null, then let's say we want to throw an error. So throw exception, and we want to put some message in here, right? So what this is effectively doing is this is stating that we're not putting the brackets here, so we're going to immediately expect a statement. And the assumption is that if you have a block or if you're parsing a block without brackets, the expectation is that you're only supposed to process one statement. So let's say we had an example where we did size is equal to 0. So if initial data is equal to null, what's going to happen is our compiler is going to see this function or this statement here, and it's going to only execute if this if statement is true, but this is going to execute all the time because it's effectively outside of the scope of this block. So we'll see that shortly, but that's just something I wanted you guys to keep in mind. I know it's simple, and I know you probably already know what this is, and I'm probably being super redundant for explaining it, but just to be comprehensive and kind of explain everything, I just want to go over that. So now we can kind of see how that actually works. So if the next token is in fact a curly brace, then what we do is we expect that curly brace. We say curly is equal to true. This denotes that we found a curly at the start of parsing our block. So we want to find a curly at the end when we're done parsing our block. So we start off with a while loop, and we just keep going forever until it's the end of the file. Of course, we want to check our error limits here, and we want to return if we have too many errors that are being processed. And then this is the entire block function. So you want to write out your code first to like process curly braces, and then you can process your other statements afterwards. So what we want to do is we want to first advance one character so that we can get the current token that we need to process. So after we get our current token, then we basically want to check to see if we have a right curly. Now this code is going to be a little bit different than what you guys have seen in the past. Typically when I was processing curly braces, I'd have a number up here or an integer that is tracking the amount of brackets that I'm processing or amount of curly braces I'm processing, but this case it's not exactly the same way, and you'll see why in a minute. So if our current token is a right curly, and we're not expecting a curly, we want to say expected left curly. To be honest, a better error might be to say unexpected symbol. So like I could use the unexpected symbol here and say unexpected symbol right curly. That's probably a much better error because the compiler doesn't know why the user put that there. After that, you want to minus minus the current token and break out. Now, again, this is one of those situations where it probably shouldn't happen. This is like a catch-all. Just to make sure you're covering your tracks, you want to cover all of the redundancies, because if you see down here, if we parse a statement and it's not a curly, we just break out immediately. So this shouldn't technically happen, but you never know, so just covering our tracks there. Now, here's why we don't use the brackets thing. So if I run into a left curly, meaning that if we have this here, so we start out with our first block, and then we put some code inside of this block, and then if we have another block inside of here with more code, then we just nest a AST instead of like doing a manual track of how many brackets we have and kind of doing everything in flat line. It's a lot better to nest it and do it recursively, because when you start processing these expressions and all of this information, it's going to be a lot better on the back end side of your compiler to just do it recursively. So what we do is we basically, if the current token is equal to that, we of course decrement the current token and parse a block, because once we call this recursively, we want to have that boolean set to true so that we can expect to close it with the opposing curly brace. So there's that. Of course, you want to check for the end of the file. If so, then we just say unexpected and then we break. And then here we kind of get to the meat and potatoes. So before I get into the actual like parsing statements, what you want to do is, of course, you want to free up your access types at the end. And the final thing you want to do is you want to, of course, check to see if you have a curly, and we've broken out of this for loop or this while loop. We want to immediately expect a right curly brace. So after you do that, you're good to go. So now let's kind of talk about the code here. So before I even get into parsing statements, of course, after you parse your statement, you want to check to see if not curly, then you want to free up your access types and break. So as you guys remember before, I mentioned in a couple videos back that I'm still working on the parser, and there's a lot of things that aren't done. So there's plenty of work that I need to do, and to be honest, we're not really going to be focusing on statements too much. So at this point, I've been developing my compiler and I have several thousands of lines of code, and I've been able to get by without having statements parsed. Basically, all of my functions just don't have any information in them, and that's totally fine because there's plenty of work to be done in regards to processing everything else. So what we're going to do is I'm just going to ignore this for now, and we'll probably come back to this in a later video, but all you should do at this point is just create a branch called AST statement so that when you're doing your unit testing, you at least know that the compiler is generating the appropriate ASTs for you, and you know that eventually, once we get to this point, there should be a statement AST inside of here. So just do that, and yeah, we'll get back to it in a little bit. So that's going to be it for today. We kind of went over how to parse a constructor. So as usual, and also I remember my last video, I showed you guys aliases. So, and I didn't show you the AST output for that. I know it was a fairly simple syntax, but just to kind of show you guys everything, I'm going to do that as well. So I'm going to create an alias of list of type var, and I'm gonna name this as numeric list. So what we're gonna see is we're gonna see basically two things. Whoops. So we're gonna see two things. We're gonna see an alias AST and then a constructor AST. So once we get here, let's see if this is the right class. All right, so we have our list. If I scroll up, yep, so this looks to be the right class. So we have our generic class called list, and we have our AST identifier list. If you guys remember, these are various identifiers to specify that it's a generic class. So if we scroll down, you can see here I immediately have a block, but this is not the block we just reviewed. This is the class block, so that's everything inside of here. And then we have two ASTs. So we have our alias declaration here, which is this, and then we also have another declaration, which is the constructor. So let's kind of go through the alias declaration first, since we didn't look at it in the last video. So when we create an alias, of course you're going to have your U type as the first thing that you're going to be processing. So we're going to have our AST U type, and then we have our numeric list. So this is going to be the name of our alias, and the U type is representing the AST that the compiler is going to have to figure out what information this U type represents to then assign it to this value. So you guys have seen this before. You've seen the formatting for U types. It's a type identifier which nests down to a reference pointer, which contains this information here and contains a U type of var. So that's pretty much how the alias declaration AST looks. So then let's kind of scroll down to the constructor declaration. So here's what we kind of went over today. So what you're going to see is you're going to see list, and you're going to see a list of access types. So I actually don't think we've seen this before, but this is typically how it would look, and this is kind of why I decided, this is actually pretty new. I did this a few weeks ago where I converted using access types into putting them in their own separate AST because it's a lot more efficient. So as you can see here, we have one AST called private, and then we have our utype arg list. And of course, we have our name of our constructor at the highest level called list. So when we look at our utype arg list, we have our parentheses here, we have our utype args, and then we only have one, so we're going to have only one AST of utype args. And our utype arg is called initial data, as you can see, and it represents a utype array of a reference pointer of type T. And of course, after that, we have multiple ASTs in this constructor declaration, so we have three. So our first one is our access types, our second one is our utype arg list, and our third and final one is our block. So that's going to represent any statements or any information that's going to go inside of here. So that's going to be it for today, guys. Hopefully that made sense. As per usual, if you guys have any questions, definitely write them in the comment section below. And as per usual, if you guys would love to help out the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you get there, definitely watch, star, and fork the repository. This gives the language a ton of more visibility and lets other developers know this language exists. Also, if you're looking to kind of stay up to date with what's going on in the day-to-day with the language, you can definitely head over to the remastered branch. This is going to be where I pretty much do almost everything, as well as while we're kind of going through this YouTube series, I'm making changes to it, making improvements, so on and so forth. And if you're interested in seeing, like, I don't know, maybe some of the things that I've done recently, you can check out the commits. Um, I typically write pretty detailed commits, so you can definitely check those out to see exactly what I've added in each of those. If you're interested in seeing anything that I've done in the past or maybe stuff that I'm looking to add in the future, you can check out the change list file. That's going to contain all of the various changes and updates that I've made in the past on previous versions. And you can check out the roadmap file, which is going to contain pretty much everything that I'm looking to add to the language or stuff that I've already done. Also, just a quick side note, I know some of you guys have mentioned to me before about supporting 32-bit and 64-bit. I just finally made the first leap on doing that, and it was a huge pain in the ass. That's this update that I just pushed today on April 10th. So that's going to contain all of the first steps for converting my language to support 32-bit operating systems. And mind you, this is a first iteration, so it is very scrappy. I'm definitely not as proud of it as I probably would be otherwise. So I'm going to be working on making improvements to this and doing further updates to support 32-bit operating systems. And hopefully I can get all of this work done before we actually get to the backend side of the compiler, because this basically touches every single bit of code. Just wanted to give that update. But yeah, so that's going to be it for today, guys. Hopefully you guys enjoyed the video. Definitely like, comment, and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.